Hello, hello, hello. Welcome back, guys. Today is Thursday, the 16th of July, and today we are going to be going through some of the syllabus points from the specification that people wanted me to go into in a bit more detail. So I know the specification is really well suited for people in the UK going through the A-level system. So it's largely in line with stuff that you've already done by the end of year 12. But some people in different systems, so if you're studying from abroad, if you're doing the IB, if your school is doing things in a slightly different order, you may not necessarily have got to everything in the specification. And I've had some specific requests to do a bit of a deep dive into those. So today should be a lot more chill than last time when we were doing our speed prep training. So today I'm planning on going through from the specification all of the calculus stuff. So the differentiation and the integration, and if we have time to then also go over probability and statistics, which is the other one that was requested. So as always, if you have specific questions, today's going to be one of those days where it's really good to pop yourself in the chat, ask specific questions if you need clarification. And as always, if you're not sort of watching this on repeat, feel free to drop a comment in the comment section or in the Discord server for a follow-up if there's something you want me to go through in a little bit more detail. Hope you guys are still surviving the summer heat. I think we're going to do a little bit of respite, if not tomorrow, then the day after. So it should hopefully calm down. All right. So with that said, let's kind of just get into it. So going to do it from the whiteboard. I've got the ESAT specification here on second screen with you guys to sort of guide me to make sure I'm covering all the points we need. But really, this is just going to be a bit of a crash course. So I'm assuming I'm going to take this from 0. So assuming you haven't covered it at all. So I'm going to start with differentiation from scratch. Note that you are able to derive this from first principles, but I'm not going to do that because it's not on the specification. So instead, we're just going to go through what the skill is. So the basic idea here is that if y is equal to x to the n, for instance, we can perform this operation called differentiation, where we differentiate, and when we differentiate, that becomes dy over dx, which can be interpreted as how does y change as x changes? And the answer is, the general rule is you bring the power down to the front, and then you subtract 1 from the power. This is true of all polynomials. It is different when you get to trigonometric functions and exponential functions, but that's not required for ESAT. You'll only get these polynomials. We also see that if there's already a number in front of the x, then when we bring the y down the front, it simply multiplies. So for instance, if we had, for instance, y is equal to x to the 5, if we were to differentiate that, that would become 5x to the 4. And if we were to have y being 3x to the minus 2, then dy by dx, we would bring that down to make that minus 6, 3 times the minus 2. And then we still need to subtract 1 from this power, which will bring it to negative 3. So just pay close attention when it's negatives that you're taking off and not just sort of blindly making that, say, minus 1, which would be a common mistake when people are starting out. So the actual skill is not too bad. Just bring the power down, subtract 1 from the power. Now, a couple of things to note when sort of doing this. If we have, for instance, y equals 5x with no power, then obviously we can kind of say that that's x to the 1. So when we differentiate, that becomes 5x to the 0, which would just be 5. So in other words, if we have anything times x, when we differentiate, the x kind of just disappears. And the other thing to note is if we are differentiating a constant, So let's say y is equal to 5. Well, we could consider 5 to be 5 times 1. And we could consider 1 to be x to the 0. So if we were to differentiate that, that 0 would come down and you would get 0x to the minus 1. In other words, just 0. So in other words, if we have just a constant, that will differentiate to 0. So let's kind of put this together. Let's come up with sort of longer polynomials and begin to apply this skill to these longer polynomials. So if y is equal to 6x cubed minus 7 over 2x to the half, x to the, I'll call that 3 over 2, plus 4x minus 3, for instance. Differentiation, you can kind of just take it term by term. So dy dx would be equal to, in this case, 18x squared minus 21 over 4 x to the, now subtract 1 from this, I'll get a half. This, the x will just disappear, I'll get 4, and the 3 will disappear to get 0. So this would be dy dx. Showing one more example, y equals 3x to the minus 2 plus 7x to the half plus 9x minus 12, for instance. If we did that, then dy dx would be equal to minus 6x to the minus 3. This half would come down, would give me 7 over 2, x to the, and you subtract 1 from that, you left with minus a half, plus 9, and then the 0 disappears. Now, this gets a little more complicated if it is not already in that differentiable form. So if we had, for instance, y equals 3 over the square root of x, the first thing you have to do is to use your power laws to rewrite it into a form you can differentiate. So using your power laws, you can rewrite that as 3x to the minus a half. Then it becomes relatively easy to differentiate. Minus 3 over 2, x to the minus 3 over 2 when I subtract 1 from that power. And so we see this type of thing a lot in the ESAT. Rewriting it in differentiable form, by which I mean x to a power, and then differentiating. So for instance, if we also have y equals x plus 3 squared all over the root of x, say, first thing you would do is square this out, and then divide by your root x. And then using your power laws, the 2 minus a half, so that would become x to the 3 over 2, plus x, 6x to the half, plus 9x to the minus a half, which we could then differentiate. 3 over 2x to the half, plus 3x to the minus a half, minus 9 over 2x to the minus 3 over 2. So using your math laws, you're sort of expanding your brackets, using your power laws to get it in this form where it's just x's to powers. And then you can just apply the simple rule and you will be able to differentiate. One last thing to note before we go more into depth about what this means is differing notation. So it would work just as well if we had said f of x is equal to I don't know, x plus 1 into x plus 2 squared. So in this case, we would expand out the brackets. X squared plus 4x plus 4, x cubed plus 5x squared plus 8x plus 4. And now if it's in this form where it's a function of x, the way we write differentiation is not dy by dx. We would instead write f dash. So this f dash means differentiate in the same way that dy dx does. So that would just be 3x squared plus 10x plus 8. Oh, and that's really annoying because that factorizes so well. Do you need to know the base changing rule at logarithms for the ESAT? I don't believe we do. Let me have a quick check. Graphs of functions, exponentials and logarithms. No, you just need to know the basic power laws, and by which I mean, sorry, the basic log laws. So no, yeah, you're good there. No worries. You'd be surprised. ESAT isn't really challenging the depth of your understanding in the way that the TMUA is. ESAT is much more going for just basic syllabus mastery, but then mastering it so well that you don't even have to think about it, so that your brain is free to apply itself to like a science or an engineering problem. So it's much more about mastery of the basics rather than niche parts of the syllabus. Okay, so that's how we differentiate. That's the skill of differentiation when it looks like y and when it looks like f of x. So let's talk now about what it means. What is the point of doing this operation? Well, what it does is it tells you, again, if you think about what this means, what I said before, it means how is y changing as we're changing x. But if you think about it, that's kind of the same thing as the gradient, change in y over change in x. And so finding a gradient with a straight line is very simple. You just do change in y over change in x. But if we have a changing function, the gradient is constantly changing. And so what differentiating does is it tells you the gradient at different values of x. So for instance, if we have a quadratic, let's just say y equals x squared minus 2x plus 1, we know we can sketch that immediately. That's going to be looking like this, where it's going to have this turning point at x equals 1. It's going to go through 1. We know it's going to have this line of symmetry at x equals 1 because it is just x minus 1 all squared. So we can look at what the gradient is doing. We can see that the gradient is very negative, and then it gets less negative, then it turns to 0, and then it turns positive. So what we can do is to see what happens when we differentiate. Differentiating, we get 2x minus 2. And so if we plug in any x value, we can work out what the gradient is at that point. So for instance, if x is equal to 0, we know that y is equal to 1, and we know that dy dx, if we plug in 0, is equal to minus 2. So what that means is the gradient of the quadratic at that specific point is equal to minus 2. So if you were to draw a straight tangent line on, and I don't have a straight line tool here, but like you would do a proper straight line. Anyway, proper straight line, you would know the coordinates of that point are 0, 1. And this differentiation has now given us the extra information that the gradient is minus 2. So in other words, differentiating is very helpful for finding the equation of a tangent at a point. So if you ever need to know the gradient, think differentiation. So the gradient is that. So now we can just say y minus 1 is equal to minus 2, x minus 0. In other words, y is equal to minus 2x plus 1 is the equation of the tangent at that point. So another example of using differentiation to find gradients would be finding, say, the normal at a point. So where is that at right angles? So let's say that's where x is equal to 3. If that's where x is equal to 3, y is equal to 16, I think. No, it's probably equal to 4, isn't it? 9, yeah, it's 9, sorry, it was 4. Transformed the graph the wrong way, apologies. And because we know, again, that dy dx was equal to 2x minus 2, when x is equal to 3, we can plug that in and get the gradient is equal to 4. But remember, the gradient, the differentiation tells us the gradient of the tangent at that point. So the gradient of the tangent is 4. So therefore, the perpendicular gradient must be minus a quarter. And therefore, we have y minus 4 is minus a quarter x minus 3. And we can multiply the 4 up and multiply the minus 1 in and say that x plus 4y minus 19 equals 0 is the equation of the normal at that point. So using differentiation to work out the tangents and the normals at different points. Because when you differentiate, you get how the gradient changes as a function of x. So if you know x, you know the gradient. And if you know the gradient, you can work out x. So for instance, if we were trying to work out where say they give us a tangent, right? A tangent to a curve, and then they asked us to work out where that point of intersection was, hypothetically. I mean, one way you could do that would be to equate the two lines. Actually, why don't we do it this way? I think this could be fun. So let's say we had a cubic this time. So let's say y is equal to 2x cubed minus 7x squared plus 3x minus 2. Right? So let's differentiate that. You get 6x squared minus 14x plus 3. Let me just run some quick mental math in order to work out what I want to do with this. So let's say we had a tangent line which we knew was y equals 3x minus 2. So in theory, what we could do to work out, like, where is that the tangent line for? Well, in theory, we could set these two equal to each other and try and solve the cubic. But that would get us 3 points of intersection, possibly. Well, definitely, actually, between the line and the curve. So that's not really going to work. But what does this tell us? Well, this tells us that the gradient of the tangent at that point is 3. So we can plug that in here and solve for x. So where is the gradient equal to 3? Well, that's when 6x squared minus 14x is equal to 0, which means that you can take an x out and get 6x minus 14 equals 0. So either x is equal to 0 or x is equal to 7 over 3. And it's quite clear here that the one it is when x equals 0, because when I plug that into both equations, I get minus 2. Now, it is true that at the point where x is equal to 7 over 3, the gradient is 3. But its equation would be different. Its intercept would be different, and you would find it by plugging the 7 over 3 back in. In ESAT non-calculator, they would never get you to do that. I just sort of made up this example. But for instance, this is sort of thinking now about how to use differentiation as a tool in your problem solving. So sometimes they give you the x coordinates and you have to work out the gradients at those points. Sometimes you have to find the perpendicular gradient at that point. But sometimes you have to use context clues from lines given to work out what the gradient is and work backwards. Well, we have someone saying, you're learning math on Khan Academy. Right now you're at Algebra 1 course at the quadratic completing the square kind of thing. Is it going to get a lot harder in the future? I'm scared. It is going to get harder, but don't be scared because it's also fun. My top recommendation to you at this stage is don't skip steps. Really deeply master what you're doing at each stage before you move on to the next, because math builds. So if you master solving quadratics by factorizing or completing the square, then the stuff that comes on top will have really solid foundations to rest on and you'll be fine. So don't worry about it. So that's sort of the differentiation in problem solving, the fact that it finds you gradients at points. One other very important application of the fact that it finds you gradients is it can find you turning points where the gradient is 0. So let's take, in fact, there was one previous one which worked out really well. So this guy here. So f of x is equal to x plus 1 and x plus 2 squared. Okay, so let's say f of x, let's go back to this guy. I actually am the level of I'm in the weird lazy spot where I would honestly rather redo the math than have to scroll up and find it. It was 5x squared and it was 8x and it was 4. Cool. And then if you differentiate that, you got 3x squared and 10x plus 8. Now, if we were to sketch this graph, what do we know? We know there's a 0. Oh, I drew that y-axis totally wrong, because what we know is that x equals -1 is a solution. We also know x equals -2 is a solution. We also know that it is x plus 2 all squared, which means that's a repeated root, which means it's a turning point there. And we also know it's an x cubed shape. So it will come from the bottom left. In fact, probably not with that gradient. So it's going to come from the bottom left, turn around there, and go back up there, and then shoot off. So something like that. So we can see that there are going to be these 2 turning points. Now, a turning point is when the gradient is equal to 0. It's where it turns around and goes back. So what we can do to solve for these turning points is to try and find, if we know how the gradient changes with x, we can try and find the specific x values where that gradient is 0. So in other words, that's just solving the quadratic. 3x squared plus 10x plus 8 equals 0. And that gives us an opportunity for me to show off the skill that I did when we went through the ESAT spec, how to factorize these harder quadratics. 3 times 8 is 24. So we need factors of 24 that add to 10. That's going to be plus 4 and plus 6. So my tip for doing this very quickly is to say 3x plus 4, 3x plus 6, and divide by 3. So that's sort of recap if you haven't seen that from before. And then that simplifies to this, which means x is equal to -4/3, or x is equal to -2. Now, we actually already knew we were going to find x equals -2 just from the shape of the graph, but this other one is x is equal to -4/3. We could then plug in, well, we don't need to plug in. We know this one is going to have a y value of 0. We could, in theory, plug this in to find the value of the y, and I am going to do that. So if I do, here the y would be, so -1/4 plus 1 is -1/3. Plus 2, so it's going to be times 2/3. So that would be -2/9. So it's -4/3 -2/9. So that is how you can use differentiation to find turning points, because at turning points, the gradient is 0, which means that dy dx is equal to 0. Gradients, tangents, normals, yeah. Stationary points, yeah. Another thing we can do here is to find out where functions are increasing or decreasing. So increasing means that the gradient is positive and the y values are getting bigger. so it's angling upwards as you move across to the right. Decreasing means the y values are getting smaller as you move to the right, and so the gradients are negative. So here it would be decreasing between x's -2 and -4/3, and it would be increasing below -2 and above 4/3. And you would do that by solving for when the gradient is positive or negative as required. So that's when something is increasing or decreasing. Now, we're actually nearly done with what you need to do for differentiation. The only other thing we need to talk about is the second differential. So let's stick with this function, actually. So we're going to stick with y equals, what was it? I keep on forgetting. X cubed, 5x squared, 8x, and 4, I believe it was. Yeah. So we're going to stick with this. So we've already seen that this is the gradient. It's how y is changing as we move through x. What we can do is do this. We can differentiate that again. So we can apply this d by dx operation again. So that's why the squared is on the d and the squared is over this whole dx. So this is differentiating again, and it's telling us how is dy dx changing as we change x. So in other words, as we're changing x, how is the gradient changing? So we do that by differentiating again, and here we just apply the simple process and we would get 6x plus 10. So this tells us how the gradient is changing at different values of x. So here, at this point where x is equal to -2, we can see on the left-hand side, the gradients are positive, and then they go to 0, and then they go to negative. So the gradients are getting smaller, and so we would expect that second derivative to be negative, because the second derivative tells us how the gradient is changing around a point. So if the gradients are changing to be more negative, then the second derivative should be negative, telling us that those gradients are decreasing. And we can see that. So when x is equal to -2, we can see that the second differential is equal to -2 as well. And because that's less than 0, it means the gradients are decreasing around that point, and we have a maximum turning point. So we get a maximum point there. When x is equal to -4/3, if we plug that in, then we can see that the second differential is equal to 2, which tells us that the gradients are increasing around that point, and therefore it's a minimum. Because the gradients are going from negative to 0 to positive. And so that is how you can use the second derivative in order to classify turning points or to understand how the gradient is changing around a point. And the equivalent in function notation would be f double dash. So that's really all there is. There's the skill of differentiating polynomials by bringing the power down and subtracting 1 from the power. There's the skill of using your power laws to get it into that form so that you can differentiate. Then there's interpreting the gradient as rates of change. So how is this thing changing? It's the gradient, and using that idea whenever you need to use a gradient. So finding tangents and normals, finding turning points where the gradient is 0, finding finding increasing or decreasing functions ranges based on whether the gradient is positive or negative, things like that. And then the final point is that second differential, tells you how the gradient is changing around a point and can be used to tell you whether you have found a maximum point where the gradients are getting smaller around that point, or a minimum point where the gradients are getting bigger. So differentiation is just applying that skill, and the interpretation is it finds you gradients and all of their applications. And that is actually all you need in terms of the ESAT spec. Hello, hello, hello. Brand new city. How's it going? Yeah, they did really well, detailed ESAT notes, which detail all the content you need to know. Yeah, so we actually went through that in a couple streams ago, the ESAT spec, but it's not good if you haven't learned it before. So I'm happy to just sort of like go through that and teach it from zero for people who don't need it. So if you're like doing the IB and your school hasn't covered differentiation yet, you're not really going to be able to learn it from the spec. Unless you mean different ESAT notes that I don't know about, in which case, tell me. Tell me what you mean about the detailed notes. Because I've got, hold on, let me see if I can show you what I've got. So I downloaded textbooks. No, it wasn't in textbooks, it was papers. Yeah, ESAT spec. Let me copy that. Let me put it here. So do you mean, now I'm going to stop that. Probably the same? I think so. So I have been through this line by line, but I kind of just like went through it. So what I'm talking about is, so what I've just done is this. So this sort of M6. So I went through all of this. But do you have notes? No, I do not have the notes. I did not know there were notes. There's a spec and notes for each section. Ooh, this is why we stream, because people know things I don't know, and that's helpful. Okay, let me go find these notes. Or if you can find the notes, that'd be great. I'm happy to hunt for these, because that is super helpful information I did not have previously. Yeah. Getting PTSD. Sorry about that, man. Hold on, let me see if I can find that. So UAT ESAT notes. ESAT prep materials. I see an ESAT guide. So hold on, this is what I'm currently looking at on the UAT website. I'm going to go for Math 2. Notes on mathematics for TMUA and ESAT. What this guide is not. There is a guide. Hello, hello, hello. That is very interesting. Okay, it's good for people to know that. So where did I get that from? So this is the UAT website, which is publicly available. They have an ESAT guide for all of these, including Math 2. See, streaming is not about necessarily what I teach you, but also what you guys can teach each other, especially when it comes to things like calculator skills. Like I pick up from students like, oh, did you know if you just press that button, it just does it for you? And I'm like, wait, it does? My hair is doing a whole situation. Oh, the physics one is mad important because you would not expect the ESAT. I would actually expect the ESAT to be all GCSE content. Oh, preparing for the PAT. The PAT. Oh, sorry. Did you know the PAT's been discontinued? Yeah, the PAT's been replaced with the ESAT. So yeah, PAT is no more. I mean, no, the PAT was just bad. Once they decided to put it online, that was the beginning of the end. But that's so. Thank you for that. Oh, ESAT. I find it very fun, but that's because I like working really, really quickly. Okay, so what I'm going to do is I'm going to go to the differentiation notes on page 110, 108. I'm going to see if I've covered everything. Let's see how good my teaching is, guys. Oh, no. He didn't say he got into both. He said he sat both tests twice. not to sort of put you down, Brand New City, but wait, you did get into both. God damn. All right. Check you out. Wait, so where are you going in September? Sorry to anyone who's like watching this after the fact. We're chatting. We're just chatting in the chat. Oh, Imperial, nice. And Oxford Physics. So which one are you taking up? I presume Oxford. That's so impressive. Well done, man. Oxford, yeah, nice. Alrighty then. So let me just okay. So now that Brand New City has given us, I mean, it's very much not all thanks to me, but oh, the interview prep videos, I like those. I think yeah, I saw very few people doing that, and I thought that would be a really useful contribution. So I'm glad you were able to use them to get your brain poked in the right way, so that you know what to expect. Genuinely curious, actually, how you found your interview compared to the videos I put out in terms of like the questions standard and like how they poked your brain. Because any feedback we get can like help me adjust the content for this year's cycle, you know. But yeah. All right. So I'll pause these notes. Your reapplicants, you kind of already know what to expect. Yeah, honestly, fair enough. So yeah, you've been through it before. Nice. Right, let me go through this. Knowledge of notation. They really teach this to you, don't they? Okay, that's really good to know. So I'll yeah, that's a hugely useful resource. Thank you so much for pointing this out. So this, if you want to sort of learn independently, I did not know they existed, and I've been doing the ESAT for years. So that's really helpful hidden gem. That they have like advanced teaching guides, really walking you through absolutely everything. So the ability to differentiate, we've talked about this. We've done this. I still like that I've given the examples I've given through walking through all the points. Yeah, so they've yeah, this is so I've kind of exactly said negative, 0, positive, quite right. And that tells you how the gradient is changing around a point. Doing your best not to pull up the ladder. Okay, this necessary and sufficient stuff is more for the TMUA, I think. Ooh. Applications of this, so finding turning points, doing a whole bunch of nonsense. So this, again, this feels a bit more TMUA. So the ESAT is more like application-based, but talking all about this necessary and sufficient stuff, it feels very TMUA. But it's possibly worth going through. So if you need a bit more than what I've done, these notes seem to be extremely good at walking you through how this all works. Special cases and subtle techniques. Inflection points, it's where the second derivative is 0. We do not expect you to have detailed knowledge of how to identify a point of inflection using differentiation. Won't ask a question that specifically involved technical issues related to points of inflection. In the comments, you said, I'd share your... Before I sent it into the void. Honestly, no worries, man. The fact that you've given me this is enough. Honestly, you've now officially done your part. I absolve you from any future responsibility. You see, you can tell when someone pops into the chat, like, oh, you! Because then I just like relax and let my personality out a lot more rather than go into general presenter mode. Oh, paying the debt. You're very welcome, man. Honestly, you can repay it by smashing Oxford. Oh, Beefotiz. My tip is don't do it. Beefo, as long as you have a spec sort of like this, I think you'll be fine. It's a Beefo. There's really no pressure with the Beefo. Yeah, I think I sat it once, did no prep, could answer no questions, and it affected me in literally no way in my life. But I would say, like, go through, see if you can find problems on YouTube, honestly, that like deal with Beefo questions, like how to approach the problem in a way that's very rigorous. Go through the spec, see if there's like anything that doesn't make sense to you. But right, so I'm now going to go through the integration stuff. And also I've got a session at 3, so I may not have enough time to also do the probability, but now that we know that these notes exist, hopefully I can drop those in the description. I can also email them to specific people I think need them so that you can kind of do that stuff on your own. Yeah, so let me get onto the integration now. So the idea behind integration, first of all, is that is the reverse of differentiation. Damn, I love how there's literally nothing I could do now for this whole of the stream that will be more useful than what you did with like a single comment in the chat. That's so funny. And also that's why I do streaming, not videos, because videos is like, oh, look at me, I know all the things. And then with streaming, you can actually get that instant feedback. Yeah, no, it's good. It's quite helpful because you guys are in the trenches, like you know what's useful. All right, so integration time. Right, so what is integration? It's the reverse of differentiation. So for instance, if y is equal to ax to the n, we saw when we differentiate, we bring the power down and then we subtract 1 from the power. Integration looks like this. So we would integrate y dx. Now this dx is the same as this dx, and it tells you what you're integrating with respect to. So it tells you what your variable is that you're playing with. So here we're playing with x, which is why we bring x's power down and subtract 1 from the power of x. When we are integrating with respect to x, it is still x that we're playing with. So the integral of ax to the n, when we're playing with x, we do the exact opposite. So in differentiation, first thing we do is bring down power, then we subtract 1 from power. So we do the same thing in reverse here, which means the first thing we do is raise 1 to the power, and then we divide by the new power. So raise 1 to power, divide by the new power. So let's sort of do a few of those. If you are integrating 2x to 2x cubed, you would raise 1, it would become 2x to the 4 all over 4, which is just x to the 4 over 2. Now, I have forgotten something, and for that I apologize, which is that we also need to add a plus c, because what we are doing is we are trying to find out what would, if integration is the opposite of differentiation, what we need to do is to ask ourselves, what would differentiate back onto my original function? So what would differentiate back onto 2x cubed? And x to the 4 over 2 absolutely would, because we would bring the power down. 4 over 2 is 2. Subtract 1 from the power, we would get our 3. But remember, when we're differentiating back down, if we had any constant, if that was plus 3, if that was plus 10, if that was minus 100, that part would disappear when we differentiate, and it would still get you back onto this initial expression. So when you are integrating, you need to remember your plus c. Yes, thank you. So the sort of catchphrase, if I ever want to punish students, because people always use this, always forget their plus c to start with. So I make them chant as like a punishment. If they ever do it, I'm like, you got to say it. And what they have to say is limits or plus c, or you will be limited to a c. So you've got to remember your plus c or limits that we're going to get onto. But first showing you the sort of basics of how to do this. So 3x to the half minus x to the quarter, for instance. If we're integrating that, raise 1 to the power becomes 3 over 2. We have to divide by 3 over 2. Raise 1 to this power, divide by the new power, and add a c. And then you can simplify. So dividing by 3 over 2 is the same as multiplying by 2 over 3, which makes that 2. Dividing by 5 over 4 is the same as multiplying by 4 over 5. So it becomes that. And then we have our plus c. And the same rules apply for getting it into the right form before we can integrate. So if we have x minus 3 all squared all over root of x, first we turn that into x squared minus 6x plus 9 all over root x, which becomes the integral of x to the 3 over 2 minus 6x to the half plus 9x to the minus a half. And we raise the power, so that becomes x to the 5 over 2 all over 5 over 2. 6x, raise the power, divide by the new power. Raise the power by 1, divide by the new power, add a c. So that's 2/5 x to the 5 over 2 minus 4x to the 3 over 2, because dividing by 3 over 2 is the same as multiplying by 2/3. And that's going to be 18x to the half plus c. The last thing to note, if we do a simple polynomial, so the integral of like x squared plus 3x plus 1 dx, that would become a third x cubed plus 3 over 2x squared in the usual way. If we have a constant, we can consider that to be times x to the 0. So you raise that to 1 and divide by the 1. So in other words, you just introduce an x. Or if that was like 2x, say, that would become 2x. So constants integrate up to like constant times x. And in fact, what I'll do is I'm going to, so I can hop between, I'm going to share this window instead. Not that window. Which window am I talking about? This one. Because then I'll be able to hop between them. Okay. So here, integration, that is the skill of integration. Raise the power, divide by the power, add a plus c. And actually, let me go to the spec first. So we've done 7.2. So what we need to do now, that's the skill. Similar to differentiation, we now need to think about the application. So differentiation found as the gradient. The application of integration is to find areas, specifically the area between a function and the x-axis. So if we used our previous example, which I like so much, y equals, what was it? It was x cubed. I want to say it was 5x squared and 8x and 4. So that was our one, which did this. Or actually, should I change it up now? Let's change it. I'm going to change it so that these are negatives. I think that might work. Hold on, let me change it to what I want it to be. So I would like the graph to look more like this one, where that's 1 and that's 2. So let's say that was x minus 1, x minus 2 squared. Expand that out. And your expanding out should get very, very fluent by the time you actually sit the ESAT. So x cubed minus 5x squared. Yeah, it is just changing those two signs. Cool. So here, if we want to find this area, this area, integration is how you find the area under a curve between the curve and the x-axis. So in this case, we want to find the area between x equals 1 and x equals 2. This form of integration we've done so far is called indefinite integration, which just finds you general expressions. but it does not find us that plus c. To find specific values for an area, we use instead what's called definite integration. So we integrate between 1 and 2, and we write those on the integral. So this tells us I'm going to integrate between x values of 1 and 2. And doing this definite integration process is how you find the area. So what you would do is you would integrate in the usual way. So that becomes, raise that to 4, divide by 4, raise that to 3, divide by 3, raise that to 2, divide by 2, make that 4x. And that's going to be between 1 and 2. What you would do here is to take the number at the top, substitute that in. So 2 to the 4 is 16, over 4 is 4. 2, so 8, so that's minus 40 over 3. When I plug in x equals 2, plugs in x equals 2 here, you get plus 16, and then you get minus 8. And you subtract from that what happens when you plug in the second number. So if I plug in 1, I'm going to get all of these guys, which I'm not going to want to have to deal with. But at least those cancel. And so now if I compute this will tell me the exact area under the curve between those things. Polynomial definite integrals, I agree, it's bad non-calc, which is why you've got to get really fluent with your fractions. You can also find ways to simplify. So for instance, here this becomes 20 minus 8 is just 12. So you can say it's 12 minus 40 over 3 minus a quarter plus 5 over 3. The over 3's, we can combine those. So 12 minus 35 over 3 minus a quarter. Now this is all going to be over 12. So 144 minus 140 over 12. 3 over 12. That's insane. So that's like 1 over 12 is the exact area. Like that nearly completely canceled out. So you would also recommend anyone doing the ESAT to learn mental math competition tricks. You're saying you found a magic website and you can't remember what it was, but it's all right because you've already given us a magical website. Your mental math is horrible. I highly recommend the skill of factor redistribution. But also doing lots of you can go, well, everyone's mental math is horrible because all of you were raised on these fancy calculators. Honestly, mission. If you can find that website and contribute 2 game-changing resources in one stream, that would be epic. That's God tier right there. Right, so that's how you find, that's how you do definite integration, right? Definite integration finds you the area under a curve between 2 points. You integrate the expression, you substitute in the top value, and you subtract off what happens when you substitute in the bottom value, and that gives you the exact area. So that gives you the area between a curve and the axis. The difference between finding a definite integral and finding the area between a curve and an axis is expected to be understood. I think what they mean here, well, let's talk about what would have happened if we had not changed it. So here we got a nice positive value because this was all above the x-axis. You found it. Oh, okay. It may. This is now. I know that I think there might be some I don't know if this is going to moderate it. If you drop it in chat, let's see if it bans it because it's an external link. If so, I don't know. Just sort of tell me what it is and I'll find it. Oh, so let's see. I'm so curious. Right. So let's talk about what would have happened if I hadn't changed that. So let's say instead we kept our original graph, which did something like this. And we wanted to find instead this area. So this was between -2 and -1. And this was for y equals, and this was just x cubed. It was plus 5 plus 10 plus 8. Is that right? No, plus 8x, 8 and 4. So if we do that instead, so it's going to be obviously very, very similar, but if we do this, in fact, I think it's very, very likely going to just be the same thing but negative. Did it send? It did not send in the chat. When you say send, what do you mean send? So it's not. No, didn't send in the chat. Yeah, it auto moderated you. I did not see the link you sent earlier. I see no links. I don't really understand the chat process yet. I really should understand the auto moderation. It's not me. It's the chat. It just does it. I don't know. Maybe I do something with my settings. Maybe if you write it out as words and don't like send it as a link. Okay. I'm gonna go searching this up. Apologies if you were following the integration, but chat is chatting and I'm interested. World mental calculation.com. Ooh. Ooh. It looks like this. Don't go too overboard with everything on here, though. You don't need most of it. So I assume you won't need like advanced calculation methods, but just sort of simple how to train for mental calculation will do. Learn more about these advanced methods. Ah, okay. All right, so this has a bunch of stuff which could, in theory, help you. They're not going to go too crazy, though. Cross multiplication is probably the main one. Nah, I'll leave it to the sort of viewer to decide how much of this you want to get into. But that's really interesting that they have this. You can multiply crazy numbers in like 5 seconds. All right. So good to know that there is this resource for helping people with their mental math. Because honestly, this is so embarrassing. Like the worst part when I was doing my speed run, I did a GCSE paper the other day in like 18 and a half minutes. But the thing that really slowed me down was adding up 3-digit numbers. I was like, oh no, I have to like do it. I couldn't do it mentally very quickly. And you're right. Anything that will speed you up does help. Great. No, thank you for that. So that is, you are officially God tier. Yeah, GCSE math paper is super helpful for Math 1. Tried to do them in 10 minutes. That's insane. I only did it in 18 and a half. 10 minutes. Is that skipping questions, though? Because you can't do all of them, presumably. Because there are things like graph sketching in a GCSE paper. That's wild. 10 minutes is berserk. Alrighty then. So actually, let's go back because I wanna. Okay, so let's go back to window for this one because I want to show you what happens here. So let's say I want to find this area here. If I do the definite integral here is going to get me. Actually, before I assume what they mean, why don't they tell me what they mean? This difference, I think what they mean. Yeah. Yeah. Okay, so this will be a good one to demonstrate. So for instance here, let's do the definite integration here between, take 2. what we're going to do here is we're going to integrate between -1, nope, -2 is smaller, and -1. We're going to integrate this guy with respect to x. When we do that, we'll get a quarter x to the 4, 5/3 x cubed. So all of these will be the same, so I don't mind rushing, but this time the signs will all be positive. Now, we're going to plug in the -1, and that will give us, that will be positive a quarter, that will be negative 5/3, that will be positive 4, that will be negative 4. And we're going to subtract all from that. What happens when we substitute in -2? So here that becomes positive 16, that becomes negative 40/3, that becomes positive 16, that becomes negative 8. So those cancel down. You get a quarter minus 5/3 minus, now again, you got the 20, so it's -12 plus 40/3. So it really is exactly the same as before, but with the sign flipped. And as before, so what that's going to give you is -12. So when we did the definite integration, we got -12. But the reason why that came out negative is because it's below the x-axis. So what that really means is the area is 12, but the definite integral gave us -12. Minus a 12th, sorry. So it's understanding that areas under the x-axis come out negative from the integration, but if we want the area, that's just a 12th. Now that starts to really matter in situations where like a graph is, so let's say the graph was doing something like this. I'm going to make up the numbers. So in this case, if we took the integral from -1 to 3, this area in the integral would come out positive. This area in the integral would come out negative, and they would kind of cancel each other out, which would be bad. So that would not tell you the true area. In order to work out the true area, you would need to integrate from -1 to 1 to get this area, and then separately work out the area, the integral from 1 to 3. That one will come out negative, and you'll just take the magnitude of that, add it to the magnitude of this guy, and that would be your total area. So that's why they're not the same. So that's 7.1. 7.2 we've talked about. This we've talked about how to do definite integration. This B is just the fact that integration is the opposite of differentiation and vice versa. Combining integrals we need to talk about. You're saying it's easier to remember the negative thing when you keep in mind the definition of an integral as a, I don't know what that is. Riemann sum? A Riemann sum? I'm probably supposed to know what that is. Yeah, that is decidedly not on the ESAT. Right, so let's talk about this combining integral stuff now. So if we had the integral between 2 and 3 of x squared plus 1, and we added on the area x of like x minus 3, what you can do in this case, if you have two integrals with the same limits, is you can just combine them into one thing, which isn't too bad. It's a similar idea to before with the differentiation, if I go all the way back to there. But it's this idea that if you're differentiating, you can differentiate the individual things and kind of just add them together. So it's the differential of that plus the differential of that plus the differential of that. And it's kind of the same thing here. So if you sort of combine them, combining two integrals, you can just form one big integral. That's one rule you need to know. The other thing you need to know is, and this is more of a TMUA thing, but it also can show up on the ESAT, like we kind of just explained. If we're integrating between 1 and 3 of something, that would be the integral. You can first integrate between 1 and 2. and then go from 2 to 3. So in this case, you kind of think of it almost like a vector. So to go from 1 to 3, we can go from 1 to 2 and then from 2 to 3. Or as is the case here, they've said to go from, if we go from 4 to 2 and then from 4 to 3, that's the same thing as going from 2 to 3. But you can see that most of this is just about the actual skill of integration and doing a little bit on the application as an area. And then there's just a few things to mop up. What if you see separation of variables on that list? First of all, which list? And second of all, I don't think you get separation of variables in ESAT. I think this is just solving it basically and then using boundary conditions to work out the value of your plus C. So, for instance, if we know, yeah, I don't think so. I'll check, but I would expect it to say something like if dy dx is equal to 2x squared minus 3x plus 7, and it goes through something that I'll work out when I decide how to make the numbers nice. What you would do is, remember, if that's that, you want to find an equation of the form y equals. The opposite of differentiation is integration, so you would integrate this. Because we're not finding an area, we don't do definite. So we would do the general, raise that, so it becomes 2/3 x cubed, raise that to 2, so that becomes, man, I really picked the wrong coefficients, plus 7x plus c. So let's say it goes through the point, let's say it goes through 6, 7, because that actually will work. And also, the more I beat this dead horse, the sooner it will actually die. So what we would say is 7 is equal to, now if you plug in 6, that would be 2/3 times 6 times 36 minus 3/2. Yeah, I'm hoping to keep it dead. I just have a feeling. Like, when did it die? Because I know the kids have been making fun of it for a while. It can't die soon enough, so that's going to become 2. So 72, that's going to be 144. That cancels down to make 18. Now, factor redistribution, let's take a 2 from there and put it onto there. So that's 6 times 9, which is 54. Plus 42 plus c. So that's 186 minus 54 plus c, which is 132 plus c. So c is minus 125. So you use your boundary conditions to work out your constant and then plug that back in. Therefore, the solution is y is 2/3 x cubed minus 3/2x squared plus 7x minus 125. Great. So that, I believe, is what they're going to say that 7.6 is. Also, while we're here, actually, so this would be the integral between 0 and 3. This is the integral between -3 and 0. For this one, you have to separately. So here, the definite integral gives you 0, because that one would cancel out with this one. In order to find out the true area, you'd have to integrate between 3 and 0, and then from 0 to 3. So here, yeah, integrate between 0 and 1, and then 1 and 2 separately. So that negative just means below, so we do 4/3 plus 2/3, which is 2, as the complete area. So you do need to integrate with the y-axis. Interesting, interesting, interesting. So here, if you instead want to find the area between the curve and the y-axis, you need to integrate x with respect to y. So before, we were integrating y with respect to x to find the area with the x-axis. Here, we're integrating x with respect to y in order to find out the area with the y-axis. This is extremely rare, and I would very much expect this to be more of a TMUA, less of an ESAT. Again, this is more TMUA. Don't worry about it for ESAT. Although I did say this would be for TMUA as well. I'm going to lie. I'm going to say this is for ESAT. Sorry about TMUA people. I'm going to keep this strictly ESAT. I like science. I can't help it. So I don't want to talk about the symmetry. So this one we've talked about. So you just have to get it into integrable form. This we've talked about. The TMUA people do have help, but also they have math brain, and I don't have math brain. I have science brain, and it just works different. I don't know how to explain it, but it is just different. Oh, so it was 6. We'll talk about trapezium rule, but first, no, where was 6? Where was 6? Where did I go? What did I do? Okay, here we go. Yeah, so solve this. You integrate it. Oh, it's just that. Yeah, exactly. So you get that. They give you boundary conditions, so they give you a point that it goes through, so you can work out your plus C and then put it back in. All right. Perfect. All right, so then the final thing to do, FTC mentioned, I've seen that. I don't know what it is. Yeah, fundamental theorem of calculus. There we go. It's just that they're the opposite of each other. Differentiation is the opposite of integration and vice versa, I assume. But again, that's math brain. You have math brain if you find that really interesting. I don't have math brain. I have science brain. I'm like, my math should be practical. If it doesn't do anything, why is it there? Yeah, it's one of those things where it has like a really fundamental sounding name, and it's just, yeah, it's not great. It is suboptimal. But final thing I've got to go through, which I haven't gone through, is this trapezium rule, which says if we've got some sort of janky integral that we want to find, or some weird area. So say we want to find this and it doesn't integrate in a very smooth way, what we can do is we can, say we want to find the area between here and here. What we can do is, in fact, yeah. So what we can do is we can break this up into strips of equal width. I did not draw this well, but whatever. And we can approximate each of these as being a trapezium. And we can work out the areas of the trapezia using the simple area of a trapezium, average of the parallel sides times the distance in between. And that, by adding them together, will give us an approximation for that area. Now, it matters because it's not the same, as you can see. It doesn't line up completely with the curve. So it will give you either an overestimate or an underestimate, or can't be determined based on the shape. So if we have a curve which is doing this, we can see that the lines all lie underneath the curve. So this would be an underestimate. If it goes up like here, similarly, the lines all lie underneath the curve, and that would also be an underestimate. I like that it looks like wings flapping, those guys. So those are underestimates. And these guys are going to be your overestimates, because the lines for the trapezia would lie above the curve. So the lines lie above the curve. Therefore, it is an overestimate when you take the area. And for ESAT, that's all you need to know. So decreasing functions, not actually no, because if you think about it, this one here is a decreasing function. So it's not about increasing, decreasing. It's about convex, concave. really this is about the exactly. So in these guys, if you think about it, it's actually here the fact that the gradients are getting bigger. So here, if we time what we did earlier, if the second derivative is positive, then it's an overestimate. And if the gradients are getting smaller, then it is an underestimate. You can kind of think of this as you like. If we were to draw a circle, this would kind of contain them all, right? So here, these ones would be your underestimates. If your curve goes like this or like this, then it's an underestimate. And if they go like this or like this, then it's an overestimate. You are right that they combine overestimate, underestimate with transformations of graphs in TMUA. So what in fact, no, I'll leave it up as being relevant to the TMUA as well, because it's not that the stuff I've done is in any way irrelevant to the TMUA, but if you guys, if anyone is, I know my people are more ESAT people. For TMUA people, there is this really detailed note thing that you can go through for anything specific. And yeah, I think that's sufficient for the ESAT. All right, where are we at now? So first derivative. So I did also have people asking about probability. Check out mean value theorem. Not for the ESAT. So do I go through probability and statistics? Let me have a quick look at that. So probability and statistics. So in the ESAT spec, I don't think it's explicitly in Math 2. I think it's more of a Math 1 thing. Yes. So if I go to the notes, let me see what there is when it comes to probability and statistics. I think it's just, yeah, that's a good point. Where is it in Math 1? So Math 1, probability and statistics, it's right at the end, isn't it? It's M6 and 7. So that's M4. Apologies that you're not seeing this, but I just want to see if it's in any way relevant. Mainly because this is a brand new document to me. You are getting this live. Oh, no. It's because I clicked just on the Math 2. Apologies. I'm being an absolute donut. So I have to switch over to the Math 1. So the Math 1 guide. Statistics, wow. Okay, like if you have any issues, if I come back to this, so I just opened the one for Math 1. Guys, look how much detail there is. This is like a 380-page document. This is a full-ass textbook. This is wild. I cannot believe I didn't know this existed. What? Game changer. Absolutely bananas. Went through the whole thing. Would not recommend. Would recommend if you don't think you are super strong on this fundamentally. So statistics and probability here, if you want them. So am I going to go through 80 pages of stats? I don't think so, but I will skip to it just to see what there is. So like 302, I know it really is a full 301. So that's stats. Two-way tables. Do I want to teach this? I suppose it's going to be tricky because the person who recommended it, I don't know exactly what the background is. Don't get caught up on the fringe stuff. Two-way tables are important though. So two-way tables are when two things are happening kind of independently. You can write out the possibilities for one option on the top, the possibilities for another option on the sort of side, and then consider what happens sort of in between. So how many are red cat? You put that in. How many are blue cat? You put that in. And if you know the, let me sort of demo how you can get there from here. So what you would need to do is if you have your thing, say, so let me just sort of black these out and see how you would have got these. So we know the total is 20. So we know 12 people preferred cats. We know 9 people preferred there. So that makes 11 to come up. That makes 8 to come up to the total of 20. If 5 preferred red to blue and cats to dogs, then that becomes 5. And what you then do is you use the totals to fill in the blanks. So therefore 4 in there, 4 in there, 7 in there, done. And that's where those numbers come from. So that's how to make use of a two-way table to see all the different outcomes. And then probabilities are the number of desired outcomes over the total number of outcomes. So in this case, the 7 out of the 20. Just keeping up with chat. So frequency tables, bar charts, boring. This is all boring. Two-way tables, boring. All of this boring, bad. Pie charts, pictograms, you're just not going to get it. Vertical line charts, not likely. I'm only going to do the stuff I think is likely to come up. So this kind of thing could come up. 3, but this would take time. I wouldn't expect this. A histogram or cumulative. I would not expect these. So I'm just going to deprioritize these. And I'm going to, yeah, so mean, median, and mode and range, I think you know, hopefully. So that's what's in there. Do you know what? What I'll do, because this is so detailed, I think I'm very happy. I'm going to keep on skimming this just to see if there's anything I want to particularly elaborate on. But I would say this, if you take yourself through this in your own time to really get an understanding, deeper understanding of anything you don't get in the spec, especially since a lot of this is GCSE level. So the probabilities are the number of desired outcomes out of the numbers of, oh, hold on a minute. Patrick, you need to account for the fact that they're evil and they hate us. Apologies, you're right. I have not counted for that. We want to explain. Yeah. The thing is, though, I think you get a pretty good understanding of the style of an ESAT question if you do all of the NSAA papers. And I think that's my idea for what to do for next stream. I'm not going to do a speedrun live solve. I think I'll go through the different types of other paper you can go through and how they can help. So I might do like a PAT paper run. I might do an old style section 2 or a new style section 2. Does it though? Hold on a minute. Challenge you on this. So someone in the chat has said the ESAT makes the NSAA and the ENGA look like year 6 at SATs. I completely disagree. Well, the reason why, you've also heard this, but then, okay, in which case, maybe I need to sit the ESAT, because when you do like the online ESAT on the UAT website, they copy and paste questions from the NSAA and the ENGA. How? I'm genuinely curious. As someone, okay, you've sat it twice, so I believe your experience here, but in what way is it harder? In what way is it harder? Is it harder? Because I think a lot of people think it's harder, but just because it's like the real one, right? Like, are the questions harder? Is there something about the format that's different? Like, I'm genuinely curious. So you think the questions are harder? So you think they're more like the questions, because remember, in the old style NSAA and ENGA, they used to start off easier and get harder. So it sounds like you're saying they're more in line with those end of paper questions that are more tricky, but like throughout the entire thing. Oh, first time catching me live. Welcome, welcome. You can. It's much better live because you can actually chat to me and I'll respond. So it's a middle ground between the difficulty of the ENGA and the old PAT. That's interesting. But you get you get 90 seconds a question, which I find the most fun. You have to completely unlearn everything about exams. Writing your working out as suicide. It depends. So that's one thing you can practice with your speedruns, right? That's something you can practice with your GCSE math and your AS math runs, is like how much you can afford not to write down. Because the more you write down, the more mental clarity you get, and the less you hold stuff in your head. So the less likely you are to make an execution error. But then you're right that it actually takes time. So the less you write down, the more time you save, and there's a trade-off. And that's something you can pick up as you move through. And that's why I talk about it like a gear shift. The more you can do mentally accurately, the better. But if you experience yourself like going through a mental shift where you're like, this one is, I'm getting a bit stuck in the mud, you have to shift gears and then start writing things out again to really get through that bit. And then you can go off and start doing mental math again. So really being self-aware about your mental process and when you need to shift gears is important and definitely worth practicing when you do your speed runs. And of course, you can't check your answers. Hope you don't make mistakes the first time. Yes, I also highly recommend, if you watch my live solves, you can see a lot of what I did about specific exam technique with the ESAT is the multiple pass system. So being very careful with your first question to give you that confidence and momentum going through the paper. If you look at a question and can't instantly see the path in your head, you skip it immediately and come back to it. So the first time through, you only do the questions that you're like super confident in and know you're going to get right in the time. And then the second pass, you come up and mop up everything else. In the real thing, it means you can flag the questions and come back to them. And take the seconds to really make sure you've read the problem, because they sometimes put stuff in that throws you, where it's got some sort of trap or a trick to it, you know? Yeah, prepare for the time pressure. Don't give yourself leniency on what you're doing. So you've got to, exactly, the pressure of the real thing is enormous. And so making sure you're really comfortable with the time conditions, I agree with you, is super important. I think you're going too far there. I don't think GCSE paper is 10 minutes. Like, I did my absolute best on the other paper the other day and got like 18 minutes 30. Like, I think 10 minutes is not reasonable. But yeah, as fast as you can is what I'd say. And I really do want to get something going where people are kind of chatting in the Discord server like, oh, I hit a new PB. And you kind of like, although I'll take it from you, it really is that bad. You got to go as fast as humanly possible. I mean, you can check out my runs. So is it worth... is it worth working your way down to below 90 seconds per question? Well, remember, that's the point of multiple passes, right? Some of the questions, and you don't know which ones, you're going to be able to do in like sub 10 seconds. You just look at the physics and you go, well, that's not that. It's not option A. It's not option B. It's option C. Done. Like, you can kind of do that. Not all of them involve like the multi-step calculations. So that's part of the exam strategy, is working out what a first pass question is that you can do in under 90 seconds a question. That builds you a time bank that you can then spend on the longer questions. So what you don't want to do is to look at a question and go, I know exactly how to do this. I can do this and this and this and this and this and this and this. But then you're like, oh no, I haven't done all of this in under 90 seconds. Oh, I've like messed up. What you should do is you should use your first pass to build up a time bank that you can spend on that to then take more than 90 seconds when you need it. So that exam technique of sort of like leveraging easier questions to give time to harder questions is part of the game. 90 seconds is the average in ESAT. So if you manage to do some of them in 20 seconds, then that's an extra 70 you get to spend on another question. So the Solomon papers were for the old style A-level math syllabus. That's what being talked about in the chat at the moment. So old style Solomon papers, I remember back in the day. So yeah, C1 and C2 were the AS papers. And so those would be the ones that pertain to Math 2 on the ESAT, if you're looking at the chat and you're curious. Cool. So you're saying worth doing, but would focus more on the C1. I agree. C1 is the sort of fundamental stuff. I'm going to quickly go through probability here and see if there's anything worth pointing out. I'm going to say no, unless there's... Yeah, I'll amend the title and take out the probabilities because I think this is fairly comprehensive. So I'll send this as a resource to people who need it. And I'll definitely drop it in the comment, the description of this video so people have access to it. That's such a game changer, like honestly. All right, so I think I'll leave that in terms of the content. I'm happy to keep chatting because you guys are bringing up some very useful stuff. So the fact that we've got that ESAT content, super helpful. The fact that you have resources, again, from chat on how to improve your mental math skills, super helpful. Which means we now have really detailed notes. And if you're doing TMUA, you already have the detailed notes on logic and proof, but then here we also have these detailed notes for the math and the physics as well. I'm actually curious, now that we're here though, what I should do while we're doing this, I want to have a look at the physics and see if there's anything weird in there. Hold on, let me queue up the chat as well. Yeah, just chatting to each other. That's fine. I'm not needed for this bit. So I'm gonna have a little look at the physics because I'm so invested now, and I don't want to give you car sickness by just sort of like quickly scanning through a thing. No, I think it'll suffice. I think now that you guys know that these deep notes exist, go through those notes on the UAT website because they come with example questions as well as just explaining the ideas. And that, I think, should suffice. So with that as further information, go through that. It's just an extra thing to go through. I would say beyond that, if you guys have things you want me to explain, I can do an even further deep dive. I'm happy with that as a sort of primer of calculus, the differentiation and integration, which I do think is the trickiest part of the Math 2 syllabus if you haven't learned it already. But I think in terms of the content, especially because I got my next session in 25 minutes, I think rather than do like a massive deep dive on a brand new topic, I'm happy with those two topics as I've done them. So yeah, I'm just gonna, the chat's just being extremely helpful. So I'm just gonna keep this going and commentate on what I'm seeing. So the the Angas and the NSAA are closer to the real thing. I agree. Remember though that the reason why they fused them both into the ESAT is because they literally copied and pasted questions across. So the ANGA has the NSAA questions just sort of jumbled up in them. So they're not, you can't like do NSAA 2016 section 1 and ENGA 2016 section 1 and expect them to be different because they're not. You would end up seeing exactly the same questions and it wouldn't be useful. So kind of stick to one the whole way through. Whiteboard paper is a very good consideration, by the way. So in the real thing, you don't have pen and paper. They give you these like flip whiteboards. And I'm not sure they erase. So I think when you run out, you have to like raise your hand and get a new one. But like it might take invigilators some time to get to you. So it's making sure that you can anticipate when you're coming up to the end and raise your hand with enough notice because you can't afford the seconds wasted for the person to get to you. Let's see what was responded to with regards to that. Yeah, spiral bound A4 paper should be fine for practicing. They said good to ask for extra paper before you start. I will say some invigilators don't do that. You need to actually need it before you ask for it. Yeah, it's like a laminated booklet, and they do not erase. Very helpful. So yeah, they don't erase, which is good for the left-handed people because it means you're right, that is not, your work isn't sort of smudging. So they have accounted for that, but it does mean you just get through it so quickly. And especially if you're like rushing, then you're probably not writing your absolute neatest or making most effective use of space. So a lot of people like go through multiple pads. um, okay, now that I'm looking in chat, do you have any advice for applying to Cambridge Natsky? Yeah, do real good at the ESAT. So the ESAT, it's extremely okay. Yeah, I will actually. Let's have this conversation. So the ESAT and the interview train very, very different skill sets. So the ESAT tests your mastery of the syllabus and the stuff you have absolutely no difficulty with that you can just sort of go sprinting off and doing it like, with absolutely no problems. Whereas the interview tests your slow, deep knowledge. So it's kind of, they might give you some ESAT style just to sort of make sure you're okay, but they'll also ask you these deeper questions which take a lot more thinking. And that's why, as part of your practice, I recommend doing alternative styles of paper. So as you're prepping for this sort of entrance campaign, you go along two parallel paths, where one is doing things like the old PAT tests or the old style NSAA section 2s, the ones with these long form questions where you sit there, you don't do it to time, and you just sort of think, can I get there? Because those are designed to help you with interview, which is part of the process, right? You're not going to do the ESAT and stop. It would be too hard to pivot if you're not used to physics at that standard. So experience hard physics as you're going through, and it will prepare you for interview as well as strengthening your physics knowledge for the ESAT. So don't abandon that as part of your process. So kind of move everything across the board together. So PAT tests, old style section 1s, that kind of long form stuff in parallel with your speed work with the GCSE and the AS papers, in parallel with your more modern style NSAA section 2s, for instance, things getting you or used to things in the style of the ESAT. I would say personal statement matters less for Oxbridge, but you want to use your personal statement to really be a bit of like a rallying cry, like a mission statement to yourself about what you're doing and why, so that you have that motivation to like do the work necessary to get through to the other side. I would not worry about college selection because they're all competitive. Just go for one you like, where you can see yourself living there for a few years. And whatever they say, you say thank you. So if you don't get in, it's because typically it's not necessarily that Oxbridge is better than other universities like Imperial. It's a very specific modality, and if your brain does not respond well to that style of teaching, it would kind of be unethical to put you through it. And so if you manage not to get an offer, then I would say be grateful that you like had a mock supervision, and then yeah. I've now been speaking for a long time about that, so I just want to see how far back I've gone on the the chat. Is there anything else I need to respond to? Most people just sort of chatting to each other rather than me. You're worried that you won't get an interview for Cambridge Phiznatsky for not doing further math. Not necessarily so. The reason why is because the further math content, I wouldn't say that's disqualifying. And the reason why is because when you go to Cambridge, there are two math streams. There's Math B for people who have done the further math and really want to push it to the next level. And then there's Math A, which is for people who haven't done the further math necessarily, where you recap a lot of the stuff like differential equations. Do I mean that? Yeah, I do mean that. That you would have done in further math. So it's by no means disqualifying, but what I would say is make sure that the math you have learned, you have mastered. because those math skills will still be important in your interview. So things like your graph sketching, things like your calculus. Because if they see that you don't have the further math, they might think it's due to a weakness in your math ability. But if you prove to them that there is no weakness in the math ability, you should be fine. As long as your predicted grades are good enough in your math and your experimental sciences, you should be fine. And I suppose it will also be interesting for you to see, because it depends on what you're applying to at Cambridge and at other colleges, what requirements there are in your ESAT. So, for instance, if you're more of someone who wants to go into the ESAT and do Math 1 Chem Phys, that might be completely fine to avoid the Math 2. Or you could show them, hey, look how confident I am in my math for the single math by doing Math 1, Math 2 Phys, for instance. Also, if you're then applying to something like engineering or physics at Imperial and they require the ESAT, they might demand Math 1, Math 2 Physics. So just be careful with your selection of options in the ESAT. Be strategic about that and really play to your strengths. I would not go into an Oxbridge entrance campaign worried about your weaknesses. Lean into your strengths. Yes, you're not doing further math, but you are doing something else. And you can bring that to the table and see if you can make a case for getting in. So it's not disqualifying, and you should back yourself. So you haven't applied. That's what you plan to do. Year 2. You already do 4 subjects, so it's going to be a big workload. I wouldn't say further math. For Oxford Physics, I agree it's a big deal. For Cambridge NatSci, I think you can get away with not doing the further math as much. I agree it's not disqualifying, but it's not an advantage, certainly. So it kind of depends on what else you're doing. But like I say, there's no reason not to do it if you think you're at that standard, because it tells you something about your confidence. Because what you don't want to do is to go, oh, I think I might not get it, so it's not even worth trying, because the psychological repercussions of that would just be bad. I think the psychological confidence it gives you to be like, no, I'm on this level. I'm like competing for a place at Cambridge because I deserve to, because I'm at that level. It raises your standard, and the preparation you do for the ESAT prepares you for your A levels more broadly. It means you're more likely to get any offers you do get, even if you miss Cambridge. It means you have a stronger personal statement because you're more confident, because you know where you're applying to. The people who are receiving your application from different universities, they are getting it in the October, which means they anticipate that you're probably an Oxbridge candidate, kind of doing that. Like there's plenty of reasons to do it, even if you think the chances are low without the further math, right? Similar to like in America, there's more than one reason to run for president, right? You can run for president. That doesn't mean you're going to get it, but sometimes they do it for different reasons. Maybe not the best parallel, because there's more than one person who gets to go to Cambridge for NatSci. But yeah, I would say go for it if you think you have a chance, right? Because because of what that tells you about yourself. Because like when you see a chance, do you just see the chance that it won't happen and decide not to try, or do you see the chance that it could happen and go for it? And I think the psychological benefits of that are huge and very worth doing. You have to do Math 1, Math 2 Phys, because in Imperial they need it for physics. Quite right. By the way, if you have a really strong Math 2, like you'd be surprised the number of people who don't have a strong Math 2. Weirdly enough, Math 1 has seemed to get worse scores across the board in recent years. But if you have strong math scores in your ESAT, I say that overcomes the fact that you don't have the further math, especially if they see what it is that you are studying and how you wouldn't be able to fit that in. But just go for it. Someone else saying, you're applying for Mech Eng, so you're going to self-teach some further math. In fact, why am I doing this? I'm not sharing screen anymore. You can come here now. You're saying you're applying for Mech Eng, so you're going to self-teach some further math mechanics modules instead of the whole curriculum. Yeah, if you're going for Mech Eng, getting some basics in rotational stuff would be helpful, because the rotation stuff I find bad. Just really bad. So you can find that there. You can also find that, by the way, in AQA optional module in the engineering physics. You get rotational mechanics. That might be good to look up on. Yeah, further mechanics is kind of weak for that, but the for mech eng, rotational mechanics, that's really good to get a head start on. How much of the interviews could focus on chemistry? You could get, you think you're good at explaining physics and math. I've had this in the past where someone was applying for Cambridge NatSci. They were applying as a math and physics specialist. And so I went, okay, so in my interviews, I was applying as a chemist specialist. So my first interview was general math and physics, like ESAT style, sort of smorgasbord, lots of questions on lots of different things. And then my second interview was a deep dive on my specialist science, which was chemistry. So I got asked the physics in my general interview. Now, what can happen is the same thing. If you're applying as a physics, I would expect a second interview to be like your deep dive interview going into the physics, into detail. But the general interview with the math can still have like the math and the chemistry and everything else. So I once had a student I told that to, I think he misinterpreted it and went, oh, they're not going to ask me chemistry. He walks in, they ask for a mechanism. He doesn't know it. He freezes, he bombs, he doesn't get in. So if you're applying for NatSci, they want to make sure you're good across the board. If you're doing chemistry A level, make sure you're prepared for chemistry questions as well. Always be prepared. You're good at chemistry problem solving, but not so much at explaining its theory. Fix that. So things like mechanisms, definitely lean into that. Don't leave those weaknesses like that. Is there anything else? You think it's very dependent on college? True. The colleges do they just you can never predict what's going to come up in interview. If it doesn't say on their website, there's no harm in emailing them. True, but they may not respond to that email. So I think a lot of the times the benefit of an interview is the fact that you have no idea what's going to happen beforehand. If you've got lots of chemistry achievements, though, could they make there be both specialized interviews? When I say specialized interviews, though, like my chemistry interview was half an hour on just the Arrhenius equation and the graph of that. So there's one which was like testing a lot of different ideas to see how I was in like my breadth. And then there was one to see how deep I could go into a problem. Not all colleges will do their interviews the same way. But you should be prepared for all types of interview. One where you have to go really deep on one problem for half an hour, and one where you have to do like lots of small questions. You may not get both, but you need to be ready for it to go in any direction. If you get an interview, they will definitely tell you the topics that come up. No, they will not. Subject? No, they will not. You're applying for NatSci. They don't have to tell you what's coming up. Like they can do some. So in my, I got questions on physics and chemistry and math and material science, actually. Material science as it pertains to the physics A-level syllabus, but I still did. Like if you're studying it, be ready to go. Like be ready to go. Do not leave yourself that vulnerability in case it comes up, right? So that student I was telling you about, he went, oh, I'm physics and math. They know I'm not like trying to be a chemistry major here. He sits down, draw me this mechanism. He had that weakness, bam, done. So you don't know. You don't know. So you've got to almost treat it like it's your AS papers. So if it's in year 12, you got to be ready. You have many beloveds. You say you miss chemistry. Literally the second I got to university, I was like, I'm going to be a chemist. This is the first day of the rest of my life. Walked into like the organic chemistry lectures and was like, nope. Like it took 6 weeks. We started organic chemistry and I was like, I'm out. I'm done. I hate this. Literally flip switch. Done. So you don't know what would happen at university. A-level chemistry, I loved. University chemistry, I wanted to just die. But yeah. All right. So we might, I think it'd be sensible. Let's sort of come to an end then. I'll have a few minutes before my next session. Thank you very much for showing up. This is my absolute favorite type of stream, guys, where lots of people show up and the chat is very active. And there's just a lot to respond to. And look, like people in the chat know things that I don't know, and you can get your information that you know sort of broadcast so that other people can benefit from it. I had no idea that I knew the spec existed. I didn't know these detailed deep dive notes existed. Yeah, saying any stream you show up to is the best stream. So yeah, this is the benefit. This is why we go live, so that you can kind of, you can poke me and I can spread things, and it's, yeah, all good. So thank you very much for showing up. Thanks for recommending this. By the way, this entire stream for doing the deep dive was just based entirely on, it was just someone said in chat in one of my streams, can you do this? And I was like, yep, cool. So yeah, keep coming. Because that's what I mean. Like, it's, if you guys ask me for something specific, then I can target it, and then I know it's effective, right? So even if I'm not streaming to like 10,000 people, at least for the people who are here, I know it's going to be super helpful if you are directly suggesting what to do, right? Because you know what you need more than I do. And given that this is meant to be kind of just tutoring to the internet, it's not a bad way to go. So with that, thank you very much, guys. Hopefully you found that useful if you don't have the background on the calculus stuff that you need for the ESAT and TMUA. Next time, I think I'm going to go through deep dive stuff on how to make use of other papers in preparation for your ESAT in particular. So with that, I'll leave you to it. Forever paying your debt. Your debt is cleared as far as I'm concerned. That was so helpful. But right, guys, enjoy the rest of, well, I would say the rest of your summer. That implies I'm not going to see you. Enjoy the rest of this heat wave while it lasts. So hopefully that will have broken by the time I next see you. And I will see you guys probably sometime next week. Thank you very much, guys. Take care. Bye-bye.